Okay. Our next speaker is Dr. John Russell, in environmental science at Trobe University since 1997. He's keenly interested in low-input sustainable agriculture, and his research into creating and maintaining productive, healthy soils is supported by a network of 8 dryland and irrigated farmers across northern Victoria. Over the past decade, John and his colleagues at Bendigo have made a major contribution to the issues of climate change, water and land management in the southern part of the Murray Darling Basin. Dr. John Russell.
Thank you. It's very pleasant to be here, and obviously this morning's session was terrific, I think, for all of us, for me. Lachlan contacted me and asked as to whether I would come and talk about bugs in the system and the issue of bugs and sustainability. And my comments will be more perhaps directed towards sustainability, and they'll be a little different from what we had this morning. I hope it's on the mark. About 15 years ago, I chose to, with my research at La Trobe, like one day a week we get for that, to basically focus on LISA, or low input sustainable agriculture. I did this because conventional agriculture, which I'd been a part of for a good while, was making great advances, but also going close to the wire, as we heard this morning, perhaps too close to the wire, in the sense of the problems of soil structure being damaged, lost, compaction, low organic matter that we've heard about this morning. We've probably, on our cropping land, we've probably halved it since European settlement. High input costs, we've heard about that from Andrew this morning, about the input costs, how crippling they can be these days and into the future, peak oil, all the rest. Obviously the need for food security, we heard about that this morning. And also the other aspect, I think that was Andrew again speaking about need for healthy soils and the healthy food and the shelf life and all those issues. Well, I'm really concerned about basically if I'm eating some of his fruit, his apples, and they're healthy, what will it do for me? As compared to the others that don't last long, what's their structure? So I'm really got a personal interest in this and have been eating quality food for a long, long, long time, probably like many of you people. Okay, so where I focused was basically with organic farmers and biodynamic farmers. So I got to know many of them and they're very sort of open and shared their knowledge, and more about that later. So a couple of things about bugs, right? You probably know a lot more, well, people here know a lot more about bugs than I do, but an aspect of the bugs is that basically our biomass, I understand there's more biomass beneath the surface of the earth than what there is above it, right? And from Pauline's figures this morning, I think I worked it out at about 0.1% of that is the microbes in terms of their mass. So the soil biota, they're living, they warm the soil because they consume sugars and they consume and they generate heat. So we actually measure the heat too when we actually go into the field. But the thing is, they have to have a relationship with the sun, just as we have a fairly interesting and daily relationship with the sun. So do those microorganisms. But the thing is, theirs is indirect. They have a relationship through a plant, and as we saw this morning, photosynthesis mostly above the surface and other things. So they have to work with a plant. So the roots have to be there. The arbusculum mycorrhiza fungi has to be there. The hypha has to be there. And as we saw, I think in one of Andrew's slides again, or it might have been one of the other speaker's slides, the tenderness really is at the end of a root, how fragile that root is as to where that exchange takes place, and basically how, we'll call those bugs, basically communicate with the plant, probably as a function of the time of day, morning, lunchtime, evening. We have different meals, and I think plants do too. Well, that's what I say to my students. Okay. So not only do plants need energy, they also need oxygen, they need to respire. Compaction's an issue with modern agriculture. How can they be there and respire if really there's no movement of air up or down? It's compacted. Also, like all living things, they need water. These are pretty simple things. How can they get to water if it's compacted, if the water runs off and it's not there? So I'm going to actually introduce you a couple of experiments that we've been doing with our students in a few moments. We do a lot of experiments in this area and a lot of work in this area. That will hopefully the two main points which will actually come out of those in relation to compaction and water infiltration. I think that was printed in 1994, and many of you would have run your eyes over that, or perhaps read lots about it in the papers in it. The thing is, as you see at the top, management in sustainable farming systems, it's a CSIRO practice. There's been an enormous amount of knowledge, right, about what we need to do. And if you read those papers, it's all laid out there. Perhaps not, the DNA details that Pauline was telling us about, but that's all new, modern and exciting science, which we might be able to use into the future. But we know a lot about sustainability. And the thing is, what I might say to Lachlan in terms of bugs in the system, I think it's sort of a bug in the system of our agriculture, in the way in which we frame the way we think about, right, where we're at and where we're having to go to with our farming practices. And obviously that's on a cusp now and that's changing, and that's probably why we're here. Myself, like others, I've learned so much from farmers. They've mentored me all the way through and basically copied their ideas and work with them. And what I can do with the university, with our students, is basically we can measure what they think might be the case. We've done a lot of that, but I'm only presenting a couple of examples with you. Obviously, through the drought, that was a major focus for all of us, right? And that how to actually manage soil moisture was a critical thing, and we did a lot of work in that area, and I'll mention one aspect in a second. Basically, aeration's been mentioned, but basically how to aerate. Andrew aerates, many of you would aerate. There's lots of ways of aerating, and there's standard machines or custom-built machines. I'll be showing you a custom-built machine in a moment that has a particular purpose. So what we're really about is basically, because organics and biodynamics, they don't really farm from the bag. They just have to deal with what they've got, right, plus preparations. So how can you then, you're actually forced to develop your soil profile. You're forced to develop your soil biota. Otherwise, really, there's not going to be much action, as basically Lynn was actually pointing out this morning, in terms of where the diversity's at and where the actual growth's going to occur. The issue which has been very much in our forefront, probably for the last 8 years or so, because of the issue of global warming, has been carbon emissions, greenhouse gases, and basically, as we, I think here would all know, that the soil is a great resource in terms of storing temporarily or permanently, I mean long-term, carbon within the soil. So we've focused on, with some of our research work, into that area. What we're aiming to do is to get the carbon deep and permanently in the subsoil. And obviously, if you're farming in this particular way, how do you do all the above with minimal inputs? And obviously, since, as John Ridderford said this morning, we've got the issue of carbon tax, emissions, and potentially initiatives for the farming community. So if I've got time, I'll make some comments on that. Okay. On that tractor, there are continuous tracks, not a wheeled device. This particular farmer back about 10 years ago, John Dowling, shifted from a farm in Deniliquin down to a new property which is developing a much larger property near Kerrang. And basically he uses a very much modified Wallace-style plough. And these have slippers. Many of you know they have slippers or shoes upon them here. And basically they go through the soil. You could do it at the right time, and they obviously the shank goes through. They disturb the soil in various ways, but they leave behind an air tunnel, which we exploit with some of our work. What he was actually starting to replicate work that he'd done in Deniliquin, whereby he would have on his property a mulch blanket, as thick as he could get it. No adjustment, no grazing, just cropping. It could be sunflower, it could be numbers of crops that he would actually grow. One pass. Once he'd prepared the soil, he'd do one pass, and the mulch, you go through the mulch on the top, lay the seeds at the same time, then he'd come back and he'd actually harvest. Still, it would be soft because he's got a mulch blanket. This is up in a 300mm rainfall area. So basically, and then he'd spend his money on cleaning the seed in the shed. Totally different approach. Right. So we're there just helping him experiment with these new developments. We've just passed through. This is as he's developing the property. You can see there's not a lot of disturbance. It was somewhat a self-mulching type of soil. And that's an air tunnel. Basically, you can run your hands down into them. That was after we did get some rain in the drought every now and again. You realise that wasn't enough to grow a crop, but you get moving at times. And obviously, without any resistance or any hard pinch, anything like this, the roots would actually go for it. So what do we do at university? We thought this is pretty good. We'll make our own machine. We've got a much smaller one because we tow it around to various sites. And we will do the same thing. You can see the shoes at the back there. And so we went over and we'd start at Ararat to a property which is, they've had merinos on there for in excess of 100 years. So you can imagine just grazing. Nothing like what it was many years ago, or nothing like what it was in the wet in terms of production. So we started actually doing our work, and you can see the lines. This must have been in about July. We had a little bit of moisture, which is a sort of ideal conditions. And Mary Ann's just opening up just to see what the results will be. And you can see there where the actual shoes have gone through. We actually couldn't get it deeper because of the mechanics and the tractor and all those things. We hadn't worked all that stuff out at that time. You can see that there's a groove on either side and a groove in the middle. That shoe wasn't as deep. So that's sort of the way it looked. About 3 months later, they put in a big mob of ewes and lambs. And then we saw this probably in January after that, another 2 or 3 months later, and then we were surprised to see that basically the mob of sheep, they had eaten all along where the actual shoes had been. Eaten it clean, as you can see. We had a series of trials on this property, and they went for about 500 metres, those runs, so that you can see there that what's been left and what's standing. So we tried to actually ask farmers as to what that would be. They'd said, well, it would have been greener, and that because more moisture would have been there, and it would have been sweeter, like the bricks numbers which we're talking about. The animals can select, as you know, very, very good in selection. So what we've done is to continue with the work, and that was some time back now. And so the mob got the first pasture, and the next year we actually monitored it, and we found that in the areas where the aeration plough had been, there was in excess, we did a whole series of tests, but basically there was in excess of 50% production, just where the plough had been. We've done the same thing for last year, and the same thing, it seems as if it's the same thing. So it's 1, 2, into its 3rd year now. This is just through aerating. Those bugs just having some oxygen and more water. You might see that we haven't got big, at the university, big stashes of money to actually do our work, but basically what we're using there is a mower and a catcher, right? And we just measure it out and do all those things, do numbers of runs, and we can get our numbers. Seems to work all right for us. Basically, I should have said before, we're engineers, no, we're not scientists, so we do a bit of dirty science, right? Okay, well, of the projects, I actually chose 3, and I deleted one. I deleted the middle one last night because I didn't think I'd have sufficient time. So, but I'll mention that in a moment. But the first is a dryland project at Serpentine in Victoria, and I'll show you our main findings from that. The last one is a dryland project near Manu, and the middle one was basically on irrigation land. A project at Murray in Victoria. I'll just mention that to you now because it's relevant to what I'm going to say a little bit later. This is a biodynamic orchard quite a large one. I think it was about 180 acres at that time. And he'd recently bought a property just next door, which is a conventional farm. And we thought, here's an opportunity. So he allowed us to work on both properties. So we did paired studies, as you saw this morning. I think Pauline was doing paired studies. And we actually set them up. And we'll show you our rigs later and some of the other work with our corers, and took a whole lot of physical samples because we can't do the other work. Took a whole lot of physical samples. And the results that we got showed that in irrigation country, where really you can overcome the effects of drought, in the biodynamic orchard, there was significantly more carbon present in the soil profile, and the carbon went down deeper, and you'll see this a bit later, it swept down unimpeded by a hard pan. So just keep that in mind for when we go to the other examples. This is the students' work, which I supervise, and that we're focusing on soil carbon sequestration, and we're wanting to do a comparison in dryland situation. It so happened that when I was at a conference at Firetown, Anuroa, perhaps 4 or 5 years ago, on biological farming, the results of biological farming, Frank Martin from Serpentine came up to me and said, "You're from the university, do you take measurements, carbon measurements?" I said, "Yeah, we sure do." He said, "Would you please come up to my property?" Now, Frank must be about 80, and then we said, "Well, look, we'll come up." So we met it all up, and when the students were ready to go, we set it up and went to see him. Obviously, he was totally cooperative, right, with everything that we wanted to do. Frank has been in the family for 100 years, and he'd made it smaller and smaller because he was 80 odd now, and his son had half, which was conventional, just farmed as it usually was. And that he had been using a new breed of sheep, merino sheep, and he had been organic for about 12 to 13 years on this property, and he really wanted to know as to whether there'd be a difference. He was pretty astute, and he was into native perennials, C4s, all those types of things. And as you know, the drought was still on when we were there, and it was pretty tough to go over his paddocks. You could there you'd see a little bit of lucerne here, or you'd see a native perennial there, wallaby grass or something else, and they were spotted and they were sort of heaped up with dust, right, around the clumps. So this is pretty hard stuff, right? So we went in there and we sorted out what we do, and then we came back. Now, we do coring. We're pretty fortunate being engineering. We've got coring machines and all the rest. We've got laboratories where we can do all the carbon testing, and we do a whole range of engineering physical tests on the soil, because we just like that suite, because it gives us lots of clues as to what might or might not be happening, salinity or pH, or you name it, we do it, right? Pentrometers, those types of issues. So we take a whole lot of samples, average up the samples, and then we see what we get. This was the type of pit. We also generally dig pits, right? Because the pits gets the students fit, right? They just don't know what work's like until a crowbar and a shovel, and you get them into it, and they strip off. It's pretty cold then. They'd strip off and they'd dig a series of pits, a couple of pits. But you can see there with that slide, I was absolutely horrified. You know, here's northern Victoria, which used to be growing a lot of great grain, great area, absolutely exhausted. In the early days when we came out pre-settlement, there would have been a mulch that high all over this, and there would have been marsupials running everywhere. We brought the sheep in within a few years, all that went and ended up in the Tasman, right? And what we've got here, then they flogged it for years and years and years and brought in different crops and superphosphate and the rest. And what we've got left on the top there is about that much topsoil. It nearly makes you cry. The clay down below, I call it brick clay, right? It's just so you make good bricks. My wife's a potter. Okay. So these are just some of the results I've selected for you. This is just a bearing pressure pentrometer test. You can see there for both the biological or the organic, right, and the conventional, that basically they're about 150. And I think this morning, again, it might have been Pauline who said between 100 and 200. I work in millimetres, right? That's where there is the a majority of worms, I think, were in those particular areas. And I think you made the comment how cultivation can be very destructive or disturbing, right, for the habitat. So you can see that the bearing obviously increased up here and went down. And what we have in here, which establishes basically the presence of a hard pan. You guys should know all about hard pans because you're probably on a lot of conventionally farmed soil. I've been on some really hard stuff where the actual taproot goes down and then it goes horizontal, right? It's so hard. Then you've got to think about not only those root penetrations, but also penetrations of grasses and crops, also the movement of water and these issues. We actually came to the conclusion when we looked at those results and others that basically a hard pan, which is probably over most of our cropping country, probably was a lot worse before, things are improving now, is that basically it's like another layer that separates the earth or the atmosphere from basically the inner part of the earth. It's just a really such a layer, right, that it's a barrier. So we'll see a little bit more about that. Okay, so what did we find with what did Frank Martin achieve over 12 to 13 odd years of basically very conscious rotational grazing? He's very well informed. He did it all and he wanted to know what it would be. So you can see there that basically he got to 3%. This is an average of a lot of values. 3% and basically over the fence and his son, same soil type. Basically, you can see it was 1.5, but getting down to about 180 millimetres, effectively they're somewhat the same, apart from a little bit of measurement error. They're somewhat the same. So what we're seeing there is that basically, if we're going to get into soil carbon sequestration, big style, direct action style, how are we going to do it if there is a hard pan separating us and basically the subsoil? So we've actually pondered that and came up with some extra trials. The other issues too, we obviously keep track of moisture content with depth. And it's fairly much of a muchness, although there's a little bit more moisture being held, probably because of the organic matter in Frank's area, in Frank's sub. And we thought we'd set up a 5-year longitudinal experiment at Frank's place. He's totally in agreement with this. And what we're, being engineers, very target orientated, we wanted to find out, of all the methods out there in agriculture, which you would have a lot of them in this hall, which is the best way in those circumstances of accelerating the sequestering of carbon in the soil. You can use shallow ripping, you can use deep ripping, you can use 500, but biodynamic 500, you can use a combination of all those, or you can use a special device and other things which were tried. So we've set up this trial to do this, and I'll show you in a moment a particular machine which we developed, and I'll tell you the purpose for it. We can't handle that area, we just haven't got the skills. we can manage the laboratories okay, and we can manage all the mechanics and soil physics, but not those. Okay, so this is the special device we developed, and you have a little look at that. This is the builder, Kevin Long. This is the hopper, and then what we have there is a tube, runs down, and the shoe, a slipper is in there, and behind that, and we have other, we're using one at that particular time when we're doing this. And when we start with one pass, we actually go down about 300 mil, create an air tunnel, and in the air tunnel, we deposit numbers of things. We've deposited char, we've deposited sheep manure, we've deposited combinations, we've sprayed with biodynamic 500, and we call that root bait, because our intention is basically to crack the hard pan, to enable the roots to get through. So when we pass, we also seed with oats, hoping that when the rain comes, the oats will vigorously run down where the shank's gone, right down to the air tunnel, and actually start the process and create, with the biota, start a community down there, and let's see what happens with Haifa and let's see what happens, because maybe glomalin might be true and we can actually chase it, and that's the intention we want to do into the future. So we're going to compare all these methods. One thing I might mention is that on top of this, we've actually put along these lines C4 perennials for the idea that maybe we can do some pasture cropping? Yeah, pasture cropping into this also later. So we've been doing it 1 year now, so we've got a little while to go. Obviously that's me, just doing a little bit of a dig out, and you might just notice how easily the soil, I didn't mean to do that, how easily the soil is actually coming out with that little hand shovel. And you can see very clearly there the areas where actually the slipper hasn't been, and where the air tunnels are actually created. What you can see here, that's in one of the air tunnels, and that's the biochar. And this is only 4 months later. You can see here a magnified view of the biochar with the roots actually already going through it. That's sort of as close as we can get. But we know that basically it's working, and we want to see how quickly the actual roots can get down through this hard pan. Here you can see more sheep manure, which is down in the air tunnel, and here I think there's a little root just there. So the process after a relatively short time was actually starting. So that was the work that we did on that property. We found out that there was a hard pan, it was impermeable, it was going to be a barrier to carbon sequestration, so we actually developed a 5-year experiment. Now, last year, some students, and these are farming lads, most of these are farming lads that I teach. They're civil engineers, but they're so interested in doing this type of work, so we just let them go for it. They wanted to look at the question in another way. So I said, well, look, there are some biodynamic farmers over in the Stall area, Ararat area, and that's where John Brewer came from. He came from Donald, and he actually knew these guys. So we said, well, what say we do some paired tests there? The reason being that basically, supposedly, with a biodynamic process, you would expect that there would be more carbon in the profile. And we thought that we'd actually test that out to see whether it was true or not. So we went ahead with the three biodynamic growers and 3 conventional growers who, everyone was totally cooperative, totally helpful. We could use their machinery and everything else, so they really helped. It so happened that the type of fellows that they all were really keen, but the biodynamic growers, I had sort of a different sense about them, and really I'd call them Andrew, Andrew and Andrew. They sort of had that vigour that Andrew Smith gave us today, right? In basically the way in which practically he has to look at situations and at the end of the day be black on the books. I know some of these biodynamic farmers reasonably well now, and I know that they're not into the banks. Right? They're black in their books. So it gives a bit of they're good farmers, so it gives a bit of an indication after a drought they've managed well. Their production is lower, but the input costs are significantly lower. When there's boom times, they don't get the big crops, but basically throughout the drought, they'd still put the headers through and actually get grain. Okay, so what you need to look at just here is what the weather was like in that area. Here we go. So this was the what we called about, everyone was saying, I think in Victoria, the perfect autumn break, right? Rain, 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 a bit more, everything was in a bit more, and then along, we were trying to get our experiment at this particular time here, but we actually couldn't. And when it came to September, we were about to do it, get the location, and this really slowed us up. So John Brewer was out with the farmer, and he said, well, look, you know, where's the boundary line between yours and Stewie's, the conventional farmer? And the biodynamic farmer said, well, look, there's the boundary, and you'll be working one side and you'll be working the other. And the biodynamic farmer said, well, look, when it rained, when we had that with a 45 mil, he said basically Stewie's place was covered, right, in water. You could see it glistening, right, and it was running off, whereas in my place, there's nothing. Okay, so I'm leading to something. So what we have here is January this year, where we had this rain here, 55, and then we had another here, 40 odd follow-up rains. All of you are so aware of the drought, of the floods, and the issues that we had with those floods, and particularly down in the flatter country in the Kerrang areas there. You're high up here, it's okay, but on the property at Serpentine, the site that I showed you where our drilling rig was, Frank said to me, I said, how are you doing, Frank? I rang him up. He said, there's 1.5 metres to 2 metres over that now. Absolutely massive amounts of water went through there, right? So you can see that that particular rain event. Now, after September, we got in with the machines and we did all our testing, etc. And this is one part I want to show you. What you can see there is basically the biodynamic, and that's basically the moisture content, and the conventional, the moisture content here. By the time we were able to get the wheels in, right, on that property, basically the actual moisture front had actually moved down. You might remember that the subsoils would have been still sort of deficient, right, in moisture, and it would have been pulling that moisture down. So that's what we're looking at. And a point to note is that in here, that represents, over a large area, an enormous amount of moisture, an enormous amount of water. Okay. That's John. Basically, just as one of our tests, we did some pretty quick infiltration tests, not ones that, ones that give us an indication as to what's going on. We do numbers of them, and John was just checking out how the infiltration test was working. So what do we get in terms of the, on this paired site, the infiltration? And you can see here that the actual infiltration rate was exceedingly high and continued on, and we know that goes for a long time. So you can imagine when you start to do the sums on these, the consequences of this, in that when I watch these processes being done, that on the conventional site, which was just 100 metres away, across the fence, or less than that probably, here, the actual water went into the top of the infiltration and then basically effectively stopped, and the amount that went in was trivial. So I can remember in September, and you guys know better than me, there was some flash flooding and the hume was closed up through Holborn. That right? Yeah, up that way. And that I know that the country that I'd been through during the drought, particularly the tail end of the drought, was looking like this. Probably not as many sheep, right, because they would have died by then, right? But you can see that type of country. Can you imagine 100 mil of rain falling on that over 4 days? Maybe 45 mil falling on that, right, in one day? Not only the damage that it does, but basically the amount of water that comes off. And what you might say too, for every drop of water that comes off, it's not available for the bugs to work with the plants so that we can harvest them. So we've done a preliminary analysis on this, and I'll show it to you now. And obviously we're going to go back and do a lot more careful measurements of infiltration rates. And since we've had that rain, we'll be checking very closely on the carbon profiles. On this particular property, we expected that the carbon profiles on the biodynamic farm would be noticeably bigger, larger at the surface and also at depth than on the conventional farm. It wasn't the case. There was absolutely no difference. And we pondered that, and we thought perhaps that's due to the drought, We discussed it with some of the people in the biodynamic farmers, and they said, yep, that's what we think it would be, but now that we've had this rain, we'll just see what happens. So we're going back again, not only to check infiltration rates and where the moisture is, but also as to whether the carbon levels explode, right? And if they don't, well, be interesting. But remember I said to you, I gave you the example of the irrigation farm that we went to. In the irrigation farm, where they'd been doing the biological farming, there was significantly more carbon in the whole food profile. That's the one I cut out last night because of time. Okay, so if you assume a 100 millimetre rainfall event, then we have to go back and do these sums more discriminately, of course. Catchments with the Upper Loddon, the Avoca and the Richard and Avon area, we took about 100 by 50 kilometres. Based on the infiltration rate differences between the conventional and the biodynamic, wait for it, the volume was about 1 million megalitres. That's 3 lake epilogues. We're talking big water. No wonder the Hume Highway, right? So I actually lecture in the design of culverts and all those types of things, right? And we know that the nature of our rain is changing. It's coming at different times, and it's more erratic and those types of things. And we know that runoff is a critical thing that you have to manage. Okay, so we're continuing our research into that area. So just in summarising, that the infiltration test we've used for a long time, and it's really the closest that we can get to basically soil structure. And that infiltration test was telling us this time, and it's told us other times, that basically the soil biota creates a structure. And if you have heavy tractors, or if you have heavy cattle, and if you have sheep running over these things all the time, particularly when it's damp, you will compact it, right? And you'll compact it, and if then you start putting overdosing with fertilisers inappropriately at times, as we heard this morning, there's a time for fertilisers and perhaps there's a time not for over-fertilising, you can then basically start to consolidate the whole deal. So, so it's about the bugs. I might just conclude on that part and just go to a third part of our research, which basically is not so much to do with the bugs directly, but it's indirectly associated with them and probably more directly with us in terms of carbon tax, climate change in the future. I might mention to you that probably like most of you, or many of you, when Copenhagen the summit failed, I was bitterly disappointed. I thought Obama being there and the rest, we could wrap up a deal and get all this done. And it didn't, and it really worried me why it didn't happen. And obviously I was reading the skeptics and all this stuff that was going on. And then I had a few very vigorous discussions with a few colleagues at the university. And I thought, look, I'm confused about this. So I actually took 2 months off this time last year, vacation time, and I actually went through, as an engineers do, I went through all the work that the IPCC has done. And it was just stabbling, and it was exciting, and all the work that's been done. But I specifically focused on the aspects of temperature. And a student had put me wise about 4 or 5 years ago, when we were travelling in a bus to Colliamberley, you'd like to check out what they're doing all up there. He was sort of pretty doubtful about what was going on. And he said, John, there is not a linear relationship between temperature, between carbon dioxide or green gas emissions and temperature. It is not a linear relationship. He was doing engineering and science. And that he was a bit of a standout. And in the class, obviously, we were discussing these things, and we used to give him a lot of space, and he'd talk about those things. So that was in the bottom of my mind. I wanted to find out that relationship. Where is that relationship, the fundamentals of that? And I searched and searched and searched, and it was very difficult to find in the IPCC material and also in the modelling. So, but eventually I found some information which was fundamental, and it was basically the initial hypothesis for the IPCC's work. And the hypothesis was about a greenhouse, the enhanced greenhouse gas effect. Does carbon dioxide in the atmosphere generate an enhanced greenhouse gas effect? Well, of course we all believe it does. But the thing is, it was a hypothesis. And Sir John Horton at the time, who was the leader of the Met Bureau in the United Kingdom, he said, we will know in a decade, or maybe two, that whether there is a result on this or temperature variation is still within natural climate change variation. So, armed with their curve and armed with the HADCRUT 3 average global temperatures, which you can pick off the net now, I actually plotted the data up. So I'll just show you what I found. This shows you the original information showing temperature here, and we're aware of, by this time, basically temperatures could be medium. That's the business as usual across here, 4 degrees. The high uncertainty line and the low uncertainty line were there, and basically from the Industrial Revolution, or when it all sort of started, the projections would actually go like this. We haven't sort of made much of an impact in reducing our carbon emissions. Perhaps we've even gone a bit over what they think. And where we are, obviously somewhere along here, we'll see in a moment, that hasn't stopped. The blue line shows you the actual measured temperatures, right? And the IPCC started off here in 1990 with their first assessment report. And that's where they started. So basically, that's where they had the hypothesis indicated on that point there as to where perhaps it would have been if there were, if the hypothesis was holding. So there's a lot on this, or a reasonable amount on this. But the key thing, what it shows, is that the IPCC's predictions for 2010 basically around this particular point here, and where we are now, where these little fly dots are, these are the actual temperatures for, as you can see, 2006, 7, 8 and 9 in that particular area. And the most recent one is very similar to 9, whisker above, just about there. So what we're looking at is basically, again, being an engineer, we're looking at, we've had a hypothesis, and basically we're setting up a big business, and basically 20 years later we find that we are, we've estimated 45% too high. It should raise a question. This is the, that little triangle. I'll go back to it in a moment. That's the little triangle. That's the little triangle just in there. The red zigzag line. Is that zigzag line there. What I've done is to, with the little pluses, you can see where this is the measured temperatures to that particular point. And in 2006, the fourth assessment report came out. That was the one upon which we confirmed all the projections and set up the world for carbon emissions. What's subsequently happened, that was 1998, the El Nino. What subsequently happened is that basically these are where the temperatures are. This particular orange line here, and that's the projections, and these are the bands. This particular orange line here for the commitment line is that basically down here, if we hold the greenhouse gases and the aerosol concentrations, if they're held constant from the year 2000, that's where our modelling would expect it to be. Where we are now is below that modelling. So, here we are at 45%. 45% below the estimate, and it looks like that the temperatures, global temperatures, are averaging out. Now, I recently returned from the UK, and when I was there, I went to Exeter University and spoke with the people who are doing the 5th assessment report for 2013. And I spoke with Professor David, I've forgotten his name at the moment, and we discussed this information. And he said, where did you get this from? I said, well, look, it's all in the reports. There it is, I'll show you. He said, interesting. Here's a mathematician. And they actually worked the numbers, confidence levels and all these types of things. And his feet weren't really on the ground, knowing that the implications, if we get this wrong, cost-wise, and putting us in the wrong direction, could be fairly serious. I must say that in the report, in the paper that we wrote in New Zealand, we said we really should be holding off for 5 years until we really know what's happening, in relation to temperatures. So after a discussion for about half an hour, I put the question to him. I said, well, look, I said, if these temperatures continue out here, and there's enormous numbers of variabilities and all the other issues, but you've got to stick with the standard data, right? And you guys can get on the web and pick it up now, right? If this continues out here for another 4 or 5 years, I said, well, what type of conclusion, a mathematician, would you draw then? He said, well, it's all over. It's not really holding. Okay, so you say, we're thinking about initiatives for farmers in the future in relation to sequestering carbon in the soil. It's a fabulous idea, right, for all the reasons we've discussed, right? And really, it needs to be done. There are problems with hard pans and the rest. But the thing is, you think back in 5 years' time, in terms of that graph where you've got it in your hands now, and you can check each year as the temperatures tick by as to where they're going to be. We suspect, some of my colleagues who are working on this, and I initially wasn't supportive, but I am getting more and more supportive of them, is that basically when you start to look at the sunspot cycles, the sunspot numbers, and what's occurred in the past in relation to those things, the delta minimum, the Maunder minimum, in the medieval warming periods, and the correlations between the sun and its complicated effects upon temperature on the Earth, is that basically it's possibly, we won't know for a while, more likely that we could be heading for cooling and not warming. I'll end.